Today we're gonna understood IoT access technologies, right? So what are the access technologies? When I say access technologies, obviously we are talking about the communication technologies, right? Obviously we are talking about the communication technologies. Now let me explain you what I mean by that and how we're gonna go ahead. So let us look at this diagram very carefully, and this diagram is trying to differentiate the communication technologies, right, or the IoT access technologies in terms of the range. If you look at this diagram, the short range, probably one of the examples that I can put over here is the Bluetooth. Even there are a lot many examples. For example, there could be an NFC, near field communication. I will not cover that NFC in the lecture, but I will record a video and upload, so probably you can watch. So there is an NFC. Even we are using this infrared, right? You know the applications of the infrared, right? Even the radio frequency tag that is useful, right? So these are very short range communication like NFC, Bluetooth, RFID, right? Infrared. This comes in the short range. If you go a little bit upward, you have something called medium range. We're gonna discuss it, right? Where I have a ZigBee, and ZigBee is designed basically based on 802.15.4, right? And there are a lot of standard along with the ZigBee also. There are non-IP based and IP based standard. We're gonna talk about that. Even the Wi-Fi, like there are different standards like A, B, G, N, ACH, even AX. A lot of standard. This comes in the medium range, right? Or maybe you can think of a long range, but it's what traditionally we are using Wi-Fi is basically for a medium range, like 150 to 200 meters, or it depends on the locations where we have deployed, right? And if you look at the long range, it could be 3G, it could be 4G, and probably in the near future we will see the 5G also, right? So this is how your communication technologies has been categorized based on the range, right? And another perspective. So basically, when you go for a long range, actually what you are creating is a WAN, right? Wide area network. When you go for a short range, what you are dealing with is the personal area network. And when you have a medium range, probably what you are dealing with is the local area network, right? So you have a personal area network, for example, let's say I have Bluetooth keyboard, I have Bluetooth mouse. Then what I'm trying to create is the personal area networks, right? The range is very limited. If I have been connected, let's say we are 10 people connected to an access point using a standard like 802.11, probably what we are trying to create is a local area network. But when you have a standard like 4G or 5G, what you are trying to do is the wide area network, right? Now, again, this communication technologies can be also categorized based on the frequency bands. And when it comes to the frequency band, there are two very important terms that you should look into. One is the licensed spectrum, another one is the unlicensed spectrum. I already said to you that in India, it would be regulated by TRAI, that is Telecom Regulatory Authority of India. So let's say in unlicensed short range, it could be Bluetooth, it could be ZigBee, it could be IEEE 802.8. We will gonna talk about that, Z-Wave, right? And there are a lot of other standards. Similarly, if you go upward, let's say wide area network. Now, even in a wide area network, there is a long range. There are two categories. One is the licensed, another one is the unlicensed. So if I talk about 4G or 4G, let's say LTE, like long-term evolution, or I will talk about 5G, they operate in the licensed spectrum. But there are some standards like LoRa, Sigfox, right? They are for long range communication, but they operate in the unlicensed spectrum, right? Still, this LoRa, Sigfox, their permissions, everything varies from country to country. For example, right now in India, if you look at from the Indian context, right, E and V band, there is a fight going on. You can look at the TRAI and other telecom authority websites, right? Whereas in other country, it has been already given as a it has been used as a free license. I mean unlicensed spectrum, E and V band, partially unlicensed, right? So there are some policy concern and everything is there, but these are the standards available. So in future, we're going to have all this technology. So what we are doing today is we are starting from this short range communication, And so obviously the first candidate that we want to pick up is the Bluetooth, right? As I said, NFC I'm not going to cover in the session, but I will record a video and will upload for all of you so you can watch it. So let me start with the Bluetooth, right? So Bluetooth is for what kind of communication? Anyone can reply me here? Bluetooth is for a short range or a long range communication. Yes, Bluetooth is a short range or a long range. Just one reply will, Okay, good. Thank you. Okay, good. Very good. So Bluetooth is for a short range and it operates in an unlicensed spectrum, right? It operates in the unlicensed spectrum, right? So you don't require to ask anyone to turn on your Bluetooth or to install. So let us look at the basic idea. It's a universal radio interface for ad hoc wireless connectivity. This is very important, friends. It says ad hoc wireless connectivity. When I say ad hoc, the meaning is that it is not permanent. It is a temporary wireless connectivity. That means when you make the connection on and the devices which are in the range, you get connected to, right? So you don't require to have that connection always. For example, let's say you are moving from one location to other location, and at your home your Bluetooth device might be connected to your television. When you go to the office or the institute, you are connecting with a mouse, for example, right? So this is what you mean by ad hoc wireless connectivity. So it's a temporary interconnecting computer and peripherals, handle devices, PDAs, cell phones, right? And it is basically a replacement of infrared data association, you can think of, right? It is embedded in other devices, right? It's a very cheap, I mean, the cost is very low, right? It's a short range communication, so probably it gives you up to 10 meters. The important parameter is it does very low power consumption and license free, and it operates in 2.4 gigahertz ISM band. I think most of you know what is ISM, right? Industrial, scientific, and medical band, which is free, and generally it is at 2.4 gigahertz. Even your Wi-Fi operates there only, right? So it is for voice and data transmission. So this is the basic idea of the Bluetooth, right? Let's go into the little bit of the history. So the story was started somewhere in the year 1994, right? And 1908 there is a Bluetooth SIG, which is called a Special Interest Group, and there is a portal for Bluetooth. If you are interested, you can visit it. And the first version was, version 1.1 was released in 2001, and in 2005 we had 250 million chips on the embedded into the devices. And if you look at the number in 2018, it's a 4 billion chips, right, which has been produced. So this is the importance of the Bluetooth. What are the key characteristics? It operates in the 2.4 gigahertz ISM band. I already said, right? ISM. It has a 79 RF channels, right? And so channel number will be started from 0. That is from 2402 megahertz, and so you can assume it's 2.4 gigahertz because, right, 2402 megahertz. Right, and the last channel, which is 78, so total 79 because we started from 0. So the last channel is 2480, right? So you can see the spectrum of each channel, right? It does something called a frequency hopping. Now, please understand, this hopping is actually the monkey wala hopping here, right? So the monkey can hop from one tree to another tree by jumping, right? So when you have a 79 channels, actually on every channel it uses a different frequency just to reduce the chances of collision, right, or interference. Rather than collision, I should say interference, right? To reduce the chances of interference, it uses the frequency hopping, right? There are two types of traffic that we can have. One is the data link, another one is the voice link. Voice link is called synchronous connection oriented, whereas the data link is called the asynchronous connection less, right? Now see, when you talk about voice link and the data link, right, you know the applications, right, where we are using. I'm just coming to that. Now in the Bluetooth, in one network, which is called a piconet, in which you can have maximum 8 devices. So one device is working as a master and the other devices are working as a slave, Hello, one device is working as a master, another devices are working as a slave. So in one network, I could have maximum 7 slave and one master. So master can communicate with the slave in both the directions, whereas slave can only communicate with the master, slave cannot communicate with the other slave. Right? This is what you mean by this Bluetooth networks. Now you can have many such network like this, and they can be interconnected via master, and that is called a scatternet. Right? And you know what is the length of the MAC address? Yes, anyone can reply me. What is the length of the MAC address? Suppose I want to know the MAC address of my machine. What is the length? Hello, boys and girls. I hope my आवाज is coming up to you, right? MAC address की लेंथ क्या है, फ्रेंड्स? MAC address, हमारा जो MAC address होता है ना मशीन का, what is the length? मैं दूसरा क्वेश्चन कर रहा हूँ, but just to correlate something with this concept, what is the length of the MAC address, and how to know that MAC address of my machine? I hope everybody is there. Oh, 57 students, nobody is replying. क्या हो गया यार? हाँ, thank you, Manav. It's a 48 bits. हाँ, good Bhargav. So 48 bits is the length of the MAC address, and to know the MAC address, the command is ipconfig/all. Yes, you are right, Drupal. Right. So basically, similarly, please understand the way you have a MAC address for your Ethernet, the way you have a MAC address for your Wi-Fi. Right. Similarly, each Bluetooth device have a Bluetooth ID. Hello. Each Bluetooth device have a Bluetooth ID, and again that Bluetooth ID length is also 48 bits, right? I hope I'm able to make the point very clear, right? So each Bluetooth device have a address which is of 48 bits, right? And let me take you further ahead, right? So this is how the communications will happen between the master and slave. So I am not taking you into that actually the detail from the electronics perspective or a communication perspective. I want to show you the Bluetooth from the computer science perspective. But let me tell you something over here. If you look at this diagram, let's say you have a master here and you have slave 1, slave 2, right? So there are two kind of channels we already said. One is the synchronous connection oriented, that is for a voice, and second one is the asynchronous connectionless, that is for a data. Now in the data, your data packet size could be a different, right? So probably what you can have is for a variable packet size, you may have a 1 slot, you may have a 3 slot for a data, or you may have a 5 slot. It depends on the kind of the data that you want to send. Right now, let us look at this Bluetooth version, and still one column is not present here. But if I have to ask you one question here, the latest version of the Bluetooth that we have is actually the 5.2, right? The latest version of the Bluetooth that came up is actually the 5.2, right? And the year is actually 20, right? Year 2020. So these are the different versions. Let us see, look at the history of Bluetooth and try to see the difference. Right here, there was no enhanced data rate, but here it was there. Right, from this version 3, we are getting very high speed, and from this version 4, it's obviously a low power, right? Low energy. That's a very important. Bluetooth low energy. Now, why the energy is very important, I will explain you just now. But these are the different standards that you have. Right, and when you look at about 5.2, you will come to know that it has a special features for the audio, and you want a special feature for the audio, the reason you know, right? So this is the protocol stack of Bluetooth. You can see this is the lowest part. What you have is the Bluetooth module radio and baseband, right? And here you have a link manager protocol, and then there is a here what you can call it is an interface, which is a host controller interface, right? And above that you have a logical link control and adaptation protocol, that is L2 cap, that's a layer, and above that you have higher layers, and you have a different kind of applications. Now you can ask me what I mean by an application over here. For example, let's say I want to connect my keyboard with the machine, right? I want to have a hands-free via Bluetooth, right? Suppose I'm using Bluetooth in our car, right? So for every application, you have a different profile of a Bluetooth, right? So this is a protocol architecture. Let me explain you a little bit about that. So at the lowest layer, what you have is the radio. You already know radio, right? It's used at 2.4 gigahertz, and from the communication perspective, these are the the technology which has been used, like GFSK is the Gaussian frequency shifting, is the modulation technology used, right? Baseband connection establishment in the piconet, addressing, packet format, timing, and power control is defined here. Then there is a link management protocol. You can see in this diagram what it does. Basically, it does link setup, authentication, and packet size. You must have an idea about pairing devices, right? So, for example, let's say you are first time turning on a Bluetooth device and you are trying to get connected with a new Bluetooth device. What do? First, you make the Bluetooth on. Then both will do inquiry, right? Then while doing an inquiry, what they will do? Actually, they will exchange their addresses. Once you have an addresses, they will try to make a pair. When they will try to make a pair, you must have remembered. It will ask you for one password. What is that password actually? Hello, boys and girls. What is that password? Right? It will ask you for pairing keys, and that's how this layer will come into the picture, like the link management protocol, right? So it says that whether you want to connect or not, and once you did the pairing, next time when you will come in the contact with the same, Bluetooth device, you don't require to really authenticate, and directly you get connected, right? So this is what you mean by this architecture, and then if you look at again diagram. Above that, what you have is the logical link control and the adaptation protocol, right? So basically, it adapts upper layer protocol to the baseband connection-led service, connection-oriented service. So this kind of service is offered. You have a service discovery protocol, right? So I already explained to you that, like device information, its ID, and then those kind of things will be covered. Now, very important thing, if you look at this diagram, from the version 4, we came to the Bluetooth low energy. Now, why this low energy is very important? See, when you talk in the context of the IoT, actually we want to deploy, let's say, a sensor or an actuator. The objective is those sensors or actuators are going to operated by, let's say, battery coin, for example. And I don't want to replace a battery every fortnight or every month. I want to make the life as long as possible. For example, I want that sensor to work for many months or many years without replacing a battery, right? So the most important parameter that we need to work on or optimize is the power consumption, right? So from that version, actually, version number 4, it's known as the BLE, which is Bluetooth low energy, right? अच्छा, ये सेल आपने देखा होगा, right? We are using this kind of cell in our wristwatch. Yes or no, right? So you might be knowing that, for example, let's say your fit belt, and you charge the fit belt for example once in a week, and let's say it has a Bluetooth. Your Bluetooth gets remain connected with the mobile phone for the entire day whenever you are waiting, right? And whenever your Bluetooth is on. So it has to manage the battery for 1 week or something like that, right? So how? So basically, it uses something called Bluetooth low energy. Let's try to look at how it works, right? So it's a blank sheet of paper design. That means it has been designed from scratch, right? It's a different to the Bluetooth Classic. So up to third version, it was a Classic, right? It's optimized for ultra low power usage. It's enable the coin cell battery use cases, right? So what is the peak current that you can generate? It's a less than 20 milliampere. Hello, less than 20 milliampere, right? And the average current is less than 5 microampere, right? So very low power consumption, and everything is optimized for lowest power consumption, short packet reduce peak current, right? For transmit, same thing for the receive time, fewer RF channels. Like in the Bluetooth Classic, you have almost 79 channels, right? Here the number of channels has been reduced, right? So why the number of channels has been reduced? Because your discovery time can be shortened, right? And so connection establishment time can be shortened, and so that you can save the power, right? It uses a single protocol. And so, what are the uses of this kind of BLE technologies actually in context of the IoT? Right now, if you please understand, the technology like BLE is not designed for a data transfer. Please understand, right? So our objective is not to transfer a movie from one mobile device to another mobile device using a Bluetooth, and that's not the objective with which Bluetooth has been designed. So if you look at from the IoT perspective, right, actually what you want to do is you want to just transfer a smaller information, very smaller amount of data, right? Maybe you want to transfer temperature, you want to transfer the speed of the vehicle, right? You just want to tell the time, right? You want to just give a status whether the network is available or not, and you want to just give a command to a PlayStation just to play, right? So please understand the amount of data that you want to transfer is very short. Second thing is, in some cases, you are not like it's not like video streaming. Continuously, you are passing. Maybe in some application you may be transmitting continuously, but most of the time it has a frequency. Let's say every 1 minute or every few hours or like that. Right? Continuously, you are not transmitting. Right? So this is very important context that you should understand. Look at this diagram, right? Bluetooth Classic and LE dual mode, it operates. We are talking about BLE, so it operates in both the mode, Classic mode. So that means it is backward compatible with the previous version. Used anywhere, BT Classic is used today, right? It has a single mode, implements only Bluetooth low energy, right? So there could be dual mode, it could be a single mode, will be used in new devices and applications only, right? These are the some of the example you can see, right? For example, here you can see the application wireless devices streaming rich content like video and audio, right? Devices that connect with both, right? And the sensor device sending small bits of data using very little energy. So when it comes to the sensor, for example, let's say you have a keyless. I mean, you don't require to insert a key in your car. So there is a technology like Bluetooth, right? Or maybe NFC, right? But Bluetooth is the more appropriate because you need that distance actually, right? So this is all about the BLE. I already said it has reduced the number of channels. So in classical Bluetooth, if you remembered how many channels were there? Hello, there were 79 channels. Here it has been reduced to 40 channels. So you can see starting from channel number 0 to channel number 39. So number of channels has been reduced. इसका फायदा क्या हुआ? आपका स्कैनिंग टाइम कम हो गया. इसका मतलब स्कैनिंग टाइम कम हुआ, इसका मतलब क्या हुआ? What is the benefit, friends? Your connection establishment time gets reduced, right? And so there are two kind of channels, 3 advertising channels, right? And 37 data channels. So there are 3 advertising channels. You can think of it as a control channel like 37, 38, and 39, right? And other are the actually the data channels, right? So that is how it has been used. Now please understand, very important concept. Let me recall. Even 802.11 also operates in a 2.4 gigahertz. 802.11. What is the दूसरा नाम of 802.11? What is the second name of 802.11? Anyone? I just want to check whether you are listening to me or not. I wish those who are listening to me, you should write in Q&A. What is the other name for 802.11? That is the question. जो सुन रहे हैं वो Q&A में इसका आंसर लिखे कि 802.11 का दूसरा नाम क्या है. Hello. Oh, there are 56 students. Where are you? Hello, you got my question or not? I'm saying that what is the other name of 802.11? Please write down. Good, Bhargav. Thank you, yaar. Thank you for your response. Those who are listening to me, write down the second name of 802.11. Okay, thank you, Bhargav. Thank you, Ishika. 3 students have replied. And we have 56 in the class who are attending my session. physically or logically, I don't know, right? I am saying that write down the other name of 802.11 if you are listening to me. જે સાંભળતા હોય એ લોકો 802.11 નું બીજું નામ Q&A સેશનમાં લખે જેથી કરીને મને ખ્યાલ આવે કે તમે મને સાંભળજો. That's it. Oh, thank you. Right. It's a Wi-Fi. Very good. It's a Wi-Fi. Wi-Fi or WLAN also you can call it. But when it comes to IEEE 802.11, we call it Wi-Fi. Wi-Fi is the dusra naam of 802.11. Now, very important story I want to tell you. You can keep replying. I'm not looking at Q&A. For example, let's say you have a 802.11 deployed in your flat, right, or tenement or your house, and you have a neighbor who also have a 802.11, right? And these two houses are very close. Let's say their wall is common. This is just, it does not show any distance. It's a common wall, like very short distance. So what will happen? This router signal may get interfere with this router signal, right? Now in 802.11, that is Wi-Fi, we have many channels. I'm not going in the detail. When I talk about Wi-Fi, I will take you there. Out of those channels, actually there are 3 non-overlapping channels, which is the channel number 1, channel number 6, and channel number 11. Please understand. There is a channel number 1, channel number 6, and channel number 11. And its spectrum is very large. Bandwidth any vadare છે, width any vadare છે, right? In 802.11. So you have a channel number 1, channel number 6, channel number 11, and they are the non-overlapping channels. So Wi-Fi will try to do optimization. If on one router you are using channel number 1, on other you might be using channel number 6 or channel number 11, right? So just to reduce the interference with the Wi-Fi, what this BLE has done, they have a 9 data channel still available which will not interfere with the 802.11. So you can see the channel number 9, 10. Here you can see in the blue, hello, channel number 9, channel number 10, channel number 21, 22, 23, channel number 33, 34, 35, and 36. These are the data channels which will not overlap with Wi-Fi channel 1, channel 6, and channel 11, which is mostly used in the Wi-Fi, which are non-overlapping channels, right? And your advertising channel, right? These 3 black, which has been represented in the black, they are also not interfering with your Wi-Fi channel. So this is how you are able to enhance the performance of the BLE, even though it operates in the same, almost at the same frequency where Wi-Fi operates, right? In fact, for Wi-Fi we have 2 frequencies, 2.4 gigahertz and 5 gigahertz. I will speak about that when we start the Wi-Fi, but this is what you need to understand, right? This is its state machine diagram. I'm not taking you into that, but this is BLE and Internet of Things perspective, right? So for example, my blood glucose is, so when you do a toothbrush, let's say it has a Bluetooth, and from that it will tell you what is your glucose, right? And let's say you use a remote control. You use a remote control, and it will tell you what is your temperature, right? And when you open the door, for example, it will tell you the pulse. Even now in every office, probably you will see when you come to the college, we may have a camera. Once you stand in front of the camera, probably your attendance will be marked and your temperature get recorded. And if the temperature is higher than some value, probably the message goes to the office. We need to take care of this person. Even he can be an employee or he can be a student also, right? So this is how it's going to work. So it has a low power, but the important thing is the data rate is very low. But this is only the kind of information that you want to pass. So BLE is very important. Please understand. And I said currently the version of Bluetooth is 5.2, where we have a special treatment for a audio, right? It has been optimized for the audio, right? So this is a very good comparison slide that you should look into. A Bluetooth LAN is an ad hoc network, which means that the network is formed spontaneously. The devices, sometimes called the gadgets, find each other and make a network. I already explained. You can have maximum 8 stations. Out of that, one is going to be the master and 7 are going to be slave. Hello, right? And this is the comparison of the Bluetooth Classic and Bluetooth Low Energy. Even the 5.2 current version is also Bluetooth Low Energy, right? And this is Bluetooth 5, which is also a low energy, right? And the difference you can see here, the range is here is maximum 100 meter, but this is a theoretical range. Practically, you may get 10 meter or like that. Like it depends on what kind of environment you are there, right? Data rate 123 Mbps, 1 Mbps here. Application throughput, right? You know the throughput is the actually the number of bits that you can transfer per second. You can see here when you go for a low energy, your throughput is getting reduced compared to this one, right? The frequency used is 2.4 gigahertz. Here the security is 56 or 128 bit in the classic Bluetooth, whereas here it is 128 bit AES, right? So it's a secure, right? And it's a robust, so it uses the CRC for error detection, right? Latency, very important. Latency is the delay. I already explained to you in the previous session, right? So here classic Bluetooth, it has 100 millisecond, whereas here it's a 6 millisecond, very important, right? You can see network topology, star, power consumption, very important parameter. It's a 1 watt. Please understand, classic Bluetooth. Here you look at the power consumption. It could be as low as this, right? And here it's a 30 milliampere. It could be, or here it has to be less than 15 milliampere, right? So this is the comparison between your classic Bluetooth and the Bluetooth low energy, right? And this is called the scatternet. So if you you know, one master, 7 slave, one master, 7 slave, those kind of multiple networks can get interconnected, and that's what you mean by the scatternet. So this is all about, friends, the Bluetooth. Let's move to the next technology. Again, we are moving in the WPAN. What I mean by WPAN is the wireless personal area network, where my range is very short, right? So let me take you to the another standard, which is called IEEE 802.15.4. Now, some of you must have a question. What is the number for Bluetooth here? It's IEEE 802. What? Bluetooth. What is the number? Anybody? You can do Google and you can tell me 802. What is the number for Bluetooth? Can you write in Q&A? What is the number for Bluetooth? Yes, I'm waiting. 802. Number I have not said, so I thought let me ask you. I'm waiting. Good. It is 802.15.1. It is 802.15. 802.15. 15 यानी 15 भैया 15.1, right? 15.1, 802.15.1. This is the number for IEEE 802.15.1 is the Bluetooth. Now we are moving to another number, IEEE 802.15.4. Some of you may have a question, why you are not talking about 802.15.2 and 15.3? If you are interested, you can do a Google search and try to look at it. But this is very important. IEEE 802.15.4. You can ask me a question, what is so important? It is actually this standard 802.15.4 is created by an alliance called YSUN, right? It defines the physical and the data link layer. And you know, the medium access layer or medium access control layer, you can say, right, a MAC layer is a part of your data link layer. So the way like 802.11, which is Wi-Fi, it also defines physical and data link layer. IEEE 802.3, which is an Ethernet, which also defines the physical and data link layer. Similarly, 802.15.4 define the physical and data link layer for a low data rate wireless communication. Short range, low data rate wireless communication. Very important. So that means it is used for a wireless personal area network, which is also known as the WPAN. Obviously, the range is going to be less than 100 meters, or sometimes it could be in terms of kilometers, but it's where we call it wireless neighborhood area networks, right? But for ZigBee it's going to be a small, reduced range, right? Bison Alliance is an industry association founded in 2012 with the goal of driving adoption of an IEEE 802.15.4 base smart utility networking standard for interoperability bearing its name. Very important. See, when it comes to the IoT, because there are a lot of players who are manufacturing different devices and interoperability is going to be a big concern, I think 802.15.4 is playing a big role there to provide an interoperability, right? So look at this different. There are different standards. For example, Wi-Fi, right, which has been created by Wi-Fi Alliance, and it is 802.11. Similarly, WiMAX, right, that is 802.16. Somebody was telling me like 802.16 for a Bluetooth, but it is for a WiMAX, right? And Wi-SUN, that is the 802.15.4, right? So the Wi-SUN Alliance performs the same function as the Wi-Fi Alliance and WiMAX forum. Each of these organization has an associated standard body as well as a commercial name. Very important, right? So basically, what we're gonna discuss before I will not stretch this session much now. Please be with me. I want to show you one or two things. I just want to tell you one or two things. Actually, when we are discussing 802.15.4, there are many technologies available on top of the 802.15.4, and one of the important access technology that I'm going to introduce to you is actually called a ZigBee, right? Even thread could be there. There are many technologies. I will speak about that also. But one of the important technology that we're gonna talk about is the ZigBee. Now, please understand in the context of the ZigBee. In the context of the ZigBee, 802.15.4 will constitute your physical and the data link layer. Obviously, a MAC layer is a part of the data link layer. And above that, whatever the protocol or the profiles are there, which has been defined by ZigBee. Right? Similarly, I can use 802.15.4 for another technology which is called, let's say, thread. Right? So whatever the upper layers above, your lower layer, that is the physical and the data link layer, there could be a definition by the thread or a 6LoWPAN. I hope you are getting what I'm trying to say. So there are a lot of technologies which has been developed based on the standard 802.15.4. So 802.15.4 defines two things, the physical layer and the data link layer, right? Now, we are talking about right now 802.15.4 as a common, that is the physical and the data link layer. So its specification uses AES with 128-bit key length as the base encryption algorithm for securing its data. So when you are using this standard like ZigBee or Thread, which are based on 802.15.4, it uses the lower level security mechanism, so you don't require to worry, right? 802.15.4 physical layer supports deployment in this 868 or 915 megahertz, right, or 2.4 gigahertz ISM bands where our Bluetooth Wi-Fi operates, right? And it offers you the data rates in the range of 20 to 250 kilobits per second. Please understand, ZigBee is not there to give you the internet speed, right? It can be used for a machine-to-machine communication, device-to-device communication, right? You need to understand in this context. I hope I have taken enough time from you guys. We'll stop here, but I would love to answer the query that you have.